In this video, we will start to set up the simulation for the case of the coolest flow. Okay, we will set up the upper pace is the moving pace with the uh, velocity equal to 2 meter per second in the from the right to the left, and the bottom pace is uh, 1 meter per second in the x direction. Okay, from the previous video we already done about the generate the mesh, and in this case in this video we will set up about the fluid property and set up the boundary condition of the fluid flow. Okay, go to our simulation with SC tetra. Okay. Okay, from the previous step, we have uh, three files. The first is model, and the second file is the octet, and the last one is the P is the mesh file. Okay, now we can drag and drop the, the mesh file to the STP. Right, you can. This is our mesh. Now you cannot see the mesh detail. We can see the mesh detail when you change the mask mode from the model to the mesh mode. Okay, this is our mode, and I will return to the model mode. Okay, now we will start the setup. Okay, in the case of setup, you can set up on the analysis condition. Double click here, and then you can see the condition with chart. The first step we will consider the analysis type, the flow. In the case of the flow in this simulation, I will consider for the laminar flow. When we click the laminar flow here, okay, the analysis type is selected. Okay, and then you can click the next step, or you can click on the basic setting. Okay, I will click on the next step. The basic setting. Okay, in this case, we will consider for the steady state, for the steady analysis, and we will start the iteration to finding the result. We start with the first cycle, and finish. I will stop when the iteration number leads to about, for example, 1,000. Sorry, 5,000 cycle. Okay, this is the basic setting we set up. And the analysis type is steady state, and we will set up the maximum cycle of iteration is 5,000. Okay, and next click to the property. Okay, in this case we will in this step we will set up the material property, right? And you can select the, for example, you can select the material property from the directory of the software. For example, if you want to use your fluid property, in the case of this is the gas, this is the liquid. Okay, and if you want to select about the liquid incompressible fluid, you can select this one. For example, this is water. If you want to select this data, right? This data incompressible flow for 20 degrees Celsius, right? You can apply. This is your, when you double click on this property, you can see the material property, right? The name of this one is the water at 25 degrees at 20 degrees Celsius, and it is the incompressible fluids, right? This is the density, and this one is viscosity, and the heat property of the Cp and thermal conductivity. Okay, this is the step of using the fluid property from the directly of of the software. Okay, in this case, we will define the fluid property. Okay, in this case, we will define the fluid property. And for this tutorial, I will set up about the density of the fluid is 1, and dynamic viscosity is also 1. Okay, we can how to set up in this property. Okay, come back to our software. Okay, if you want to create fluid, your fluid, you can click on the new, on the material property, click new, right? And material name, I will define the name is my fluid. Okay, in this case, we will select, we will define the fluid property for the density is 1 cubic kilogram per cubic meter, and viscosity is also 1 Pascal second. Okay, for the CP and thermal conductivity will be uh, set up when you want to calculate with the energy equation. Okay, but in this case we only calculation of only the four property. Okay, therefore we set up only the density and viscosity. Okay, and group name we can I will set the group name in the liquid, and the subgroup I will select for the incompressible, and the type I will select for the incompressible fluid. Okay, click. Okay, and then if we want to use, right, you can see this is fluid, incompressible fluid, right? This is our fluid. We will, if you want to use this fluid, you can select the fluid and then click apply, right? Your material 1 is changed to the fluid is my fluid. Okay, click next step. Okay, and then initial condition. Okay, in this step you can, maybe you no need to set up about the initial condition, because this software will generate the default of the initial value, right? Depend on your setup. For example, the inlet value in the boundary condition value or so on. Okay, we will ignore about the initial condition. Okay, next go to the default boundary. Okay, in the case of the undefined, right? In the case of undefined, the default of the boundary condition is free slip wall, right? Free slip wall, and you can set up with station. We can change to the stationary wall or the so on. But I will keep the default with the free slip wall. Okay, and go to the next of the boundary condition. Click the next. Okay, this step is really important of your simulation. Okay. Okay, come back to our simulation. Okay, for the quiz flow, I will set up the u velocity in the top is equal to minus 2 meter per second when the positive x from the light from the left to the right. Okay, this is we will set up the moving velocity of the wall. Okay, for the top wall, right? In the boundary condition, select the top wall. In this case, we will define the wall condition. Okay, condition name we can define for the moving top wall. Okay, and the default is free slip and click P-slip, and then the wall condition, we will change the wall condition from the stationary to the moving wall, right? The moving wall. Okay, depend on the coordinates of the software. Okay, we will define the magnitudes of the wall velocity at the x direction. In the top, I will define is -2 meter per second, because of positive 2 in the x positive direction. Okay, this is finished about the wall condition. And the wall type, I will use the smooth surface. Okay, and the bottom wall, we will define the wall condition, right? The name of this condition I will define about the moving wall, the moving bottom wall. Okay, unclick V-slip wall and define the moving wall parallel to or the translation velocity in the x direction. The magnitude of the x direction is positive 1 meter per second. Is positive 1 meter per second. The wall is smooth wall. Click OK. And then now finish. Okay, we finish about the top and the bottom wall. For the boundary condition of the inlet and outlet, the inlet here and the outlet is here. In the inlet, I will define about the property of this boundary condition. I will define by using the natural inflow and outflow, right? Because of this is our domain, right? Okay, this is our domain. The flow is velocity of the near to the top. Okay, in this region is the outflow, but in the bottom, right, the moving velocity of the bottom wall in the x positive in this region is the inflow, right? That's why we select the natural inflow and outflow for the inlets and also for the outlet too. Okay, in the inlet and the outlet, I will click OK, control the inlet and outlet, and I will select by using the wall condition. I'm sorry, for the natural inflow and outflow, right? I will define the condition in outflow, okay, and then click OK about this property. And the symmetry, right? The symmetry 1 and symmetry 2. Okay, because of this model, we consider this for the two-dimensional simulation. Okay, in this case, we should to define the boundary condition of this model by using the residue element center wall. Right, we use this condition, residue element center wall condition. Okay, we will use this similarly with the the symmetry boundary condition. Okay, the type of this wall is free-slip wall, and we will set symmetry. Okay, please use the free-slip is the symmetry and click free-slip wall. Okay. Okay, we finished about the setup of the boundary condition. Okay. And the next step is the sort condition. Okay, known as to set up for source condition for this example. Okay, and next go to the server setting. Okay, in the case of server setting, the basic setting for the server, do you remember that about the relaxation factor for the each of the parameter, right? The V, the U, V, W, velocity, P, pressure, right? If you want T and temperature, K and epsilon. Okay, you can select and the relaxation factor. This is the update value for the news and the old value of interlation. Okay, but in this case I will use for the default the of the program. Okay, and next we will go to the about the convergence criteria. Okay, for the convergence criteria, the first we specify the convergence criteria. Okay, we'll stop by convergence after start with 50 cycle. Okay, do you remember that? There are two cases of this solution will stop. The first one when the calculation reaches the the final cycle, that is 5,000 cycle, or if you set the server setting and set the convergence criteria, and we will set about the residual, right? I will set about the residual using the average residual for, I will set only for the U, V, and W velocity. And this case is 1, 2, 3, 4. Okay, I will set about, okay, I will set the average. I will set the residual of the accelerate velocity, U velocity is lower than 1.5. I'm sorry, 10 minus 5. Okay, and also for the V velocity, V and W. Okay, from this step, you can say that the calculation will stop due to listen. The first when the convergence criteria list of the U, V, W velocity, the residual of this value is lower than 10 minus 5, your calculation will stop. Or if your calculation is cannot reduce the residual below the targets, okay, and your calculation will stop when calculation leads to the final cycle is 5,000. Okay, you see the meaning of set up about the convergence criteria of U, V, and W, right? The residual of U, V, and W equation. Okay, and next go to the output file. Okay, I will in this is really simple simulation. I will use the output parameter. We will not sharing about the output velocity. The next we will go to the file name. Okay, in this case it's really important. Okay, please consider about this one. The types, the default, this is the defaults depend on your maybe depend on our image file, right? This is our image file. It's parallel page, makes it one. And in this case, I will change about you should keep the inlet P is the mesh file. The input file is right. The input file is this file. Okay, and we will change only two file, an output file and graphic file. Okay, and click on the file name and change on this file and uh, use the name of this one is the ex or ex1 that fluid flow. Okay, fluid flow. Click control, and this is also fluid flow. Okay, we will change only two file, right? We keep the input file and change only the who is for. Okay, now we finish about the file name and next. Okay, finish. And in this step, we should to click on the save file and finish. Okay, in this case, I will save ex01 and we will use the clue s4. Okay, save. Okay, now you will see your S file, right? S file is the setup. How to say? S file is the setup file, and it will be used to the calculation. Okay, this is S file, and you can check, right? You can check. This is our model and the material. The material is the name is my material. You can double click to see the your fluid property, right? Please confirm this again, and then you can check the bodily condition, the inflow and outflow. You can see there are two bodily, the inlet and outlet are set up to be the inflow and outflow bodily condition, right? And the moving wall, right? You see the moving wall. Double click, you can see the moving wall. The regions in the top wall. The detail, right, is -2 meter per second. The top wall, moving wall, and symmetry. Okay, now we finish the step of the setup. Okay, we finish and the step of the setup. Okay, please click again. Please right click again on the. If you have some update of your setup, you can save your S file by select the analysis condition and right click, then select the save file, right? The type of your file is S file. Okay, select the original one of your file name and click save. Replace yes. Okay, now we finish about the step of the setup, right? Now we finish the setting and the set analysis condition. Okay, summary of this video, we finish in the step of the preprocessor, right? Generate the model, generate the mesh, and set up the condition of calculation. And the next, we will go to the second step of the CFD, that is the calculation by using the SCT solver. Okay, now we have Okay, we finished. Now we have the S file for using in the calculation in the SCT solver. Okay. Okay, thank you very much for your attention in this video of the set analysis condition. Okay, thank you and see you to the next video of calculation